Okay, welcome to Introduction to Data Mining course, ITS 632. In these lectures, we're going to discuss about data mining tasks and applications. This is our Unit 1, lecture number 2. So data mining tasks, we have the prediction methods and also description methods. Prediction methods means we are going to use some variables to predict some future values or unknown variable. Example would be the stock market. Maybe we may know the price of a stock today, the economic situation today, and we can use this data to predict the future price of the stock. And another example would be we have advertisement expenses. We are trying to see if advertisement expenses can be used to predict revenue generation. Which means if we increase the amount of money we spend on advertisement, will that also increase our revenue or the company's revenue? So this would be a prediction method. Normally we use something we call the regression analysis. And if it's a continuum or quantitative data or continuous value. We also have the description methods. Here we're going to find a human interpretable patterns that describe the data. So the data mining tasks, we have classification, which is a predictive. Cross-story is descriptive. And also association rule discovery is also a descriptive. Then we have a sequential pattern discovery, descriptive. Regression is predictive. Deviation detection is also predictive. So example, in classification, normally our output value or data will be categorical. Example, a patient have a disease A, true or false, or yes or no. This will be classification. But regression, the stock price will be $100, $50. Use again, regression classification is a predictive. By regression, we are predicting values like a stock price or income generated. Whereas classification, we are predicting a categorical data. Example, is a disease, yes or no. And cross-story is descriptive. The reason why, because we are not predicting anything. So, but we want to, that's why it's called cross-story. We want to find the similarities in the data set. When we have a group of data set that have the same attribute or the same values, they are similar, we group them together as one cluster. If we have another data that is similar from the first cluster, then we group it as a cluster number 2. So similar values or data will be clustered together. The similar values will be clustered differently. So it's descriptive. Association rule discovery, we want to find if there's 2 or more variables have any relationship association. For example, I will go to the supermarket. What is the chance that if I buy a bread, I may also buy, let's say, a peanut butter or a brick or a meat? What is the relationship between a customer buying a meat and also buying or cooking oil? So that's we're trying to find association between 2 or more variables. Sequential pattern discovery, again, it's almost same as association, but there's slight different. So in this case, let's say we have a sequence of events. We say if event A and B happen, then C will surely happen. Or if event A and B happen, then D will surely happen. So it's a sequential pattern discovery, which again use the same concept as association rule discovery. In association rule discovery, we are trying to find a relationship between 2 or more variables. If I go to the supermarket and I buy a bread, will I buy peanut butter or beer or egg? But in sequential pattern, now I want to find out if you buy peanut butter, what will be the next thing you buy? Egg. What will be the next thing? So we are finding the sequential pattern discovery. So sequential pattern discovery is commonly used in, example would be computational biology, in a DNA sequence. We know if AGTC, if I have AGTTC, it means you have a specific disease. If I have ATTGC, it means different disease. So it's the sequence of the nucleotides will determine the disease. Regression, as we said, is the same as classification, is predictive. By regression, again, we are predicting a value, a quantitative value or continuous value. Deviation detection also is a predictive. Here we want to predict if there's any, for example, I'm using credit card. I have a credit card. I live in New York. Most of them, I use my credit card regularly. The system was able to build my expenses or my profile of how I use my credit card. Most of the time I use my credit card in New York, 99%, and I don't buy an item more than $1,000. All of a sudden, I'm in Texas buying something over $10,000. That's deviation. So the system will see the deviation detection, detect the deviation of my purchasing behavior. And maybe to ring an alarm, or they may reject the sales, or they want to contact the person. They will contact me and make sure I'm the one using the credit card. So deviation detection can be used again to find any deviation from a behavior, even a network intrusion detection system. Also, we can use the deviation detection. So these are the major data mining tasks, and each task have different algorithms. So we start with the classification and example. So the definition said in classification, we have two steps. The first step, we need a training set. The training set means we have the data attribute with also the class label. The class is very important because that's, for example, we are going to use the training set to build a model. Then later we use what we call the test set. The test set doesn't have the class label to test how accurate the accuracy or the precision of the model. So what is a training set? A good example will be, we have a data set about patients. These patients have a disease A. A training set means we already know the patient's attributes and we know that they have disease A. These are the patients that we diagnosed in our hospital for the past, let's say, 5 years, and they all have the same type of disease. We have all the possible attributes that we think it can contribute to the disease or the clinical data by the patients. This is a training set. Why? Because we have the class level. The class level tells us these patients all have the disease. So if that's the case, I'm going to build a model. This model is going to learn how to detect if a patient have that specific disease A, the class level. Then after that, we are going to test this model using a patient, but we are not going to tell, so this time we are not using the training set. We are not going to tell the model that what is the class level. The class level, we don't know it. So now the model have to predict if the patient have disease A or not. So that's the definition. Given a collection of record, which is training set, each record contains a set of attributes. This can be the patient temperature, the blood pressure, or the DNA sequence, whatever the attributes are for the patient. An example is a patient. We can have any application, let's say a customer, expenses, income, age, etc. But one of the attributes is the class, which is the outcome. Now find a model for the class attribute as a function of the values of other attributes. So here we build a model with a training set. Now what is our goal? Previously unknown records should be able to assign the class as accurate as possible. So we may have a test data now to see if the model can assign the right class to it. Let's say a patient has a cancer, yes or no. So a test set is used to determine the accuracy of the model. Usually, the given data set is divided into training and test set. With training set used to build a model and a test set used to validate it. Again, as time goes on, we have a chapter for classification, and we are going to use the Waker application to try this concept. We are going to have a training set, we build our model, then we use the test set to test how the model is. And there are so many ways to get a test set. We can either divide the training set into two and use one part as a test set. In Waker, the application will remove the values. We turn the training set to a test set. That means a data with no class label. Or we can have what we call the cross-validation with a number of folds. We could say n fold, it can be 2-fold, 3-fold. We may discuss all this as time goes on. Right now, we should know the definition of classification is two-step. We have a training set, we use the training set to build a model. Then we have a test set, we use the test set to see how accuracy the model is. So this is an example given to us. Here we have a training set here, a training data set. The cheat is our class label. So this data set is about taxpayers. So we have, again, most of the time, data we always want to keep privacy, data privacy. So you can see here we are not using the taxpayer's name because unless if the name will determine the class, I don't think a name can determine whether a taxpayer will cheat on their tax returns. So we use the tax ID, a special number assigned to each taxpayer. Now we have the categorical data for refund. We want to know if the most likely the taxpayers who get refund, they are not going to cheat. Or the marital status. Most of the time, singles pay more tax than marriage couple pay. So that can have an effect on the cheating or not. And also taxable income is important. The higher your income, the more tax you pay. So who knows, the more money you make, the chance of cheating on tax is possible. So this is our data set. This data set is a training data set because we have the class label, we see whether the taxpayer cheat or not. And this is what we know. So now we are going to use this training set with the learning classifier, which this will be our algorithm. Let's say we are going to use a decision trees or support vector machine. We will discuss all this in the future. We are going to use the algorithm to build a model. Now, when we build a model finish, we get our test set. So you can see the test set here in the cheat section. We have nothing, question mark. So now the model have to predict whether all these taxpayers who cheat and who didn't. So again, two steps. We have our training set about taxpayers. We use it to build a model with the classification algorithm. After we build a model finish, we use a test set. Test set means in the class level, we don't have anything. We don't have no any information. Now the model will have to predict all this for us. And based on accuracy, we may accept the model or we may modify the process. We know the process of data mining tasks. The first thing we need to select our data. Next, we need to prepare the data preparation. The reason why we need to prepare our data, most of the time, a raw data always have an error. If it doesn't have no error, maybe we may have a missing value. Or if no missing value, there may be duplicates. So our goal is to remove these three items: errors from the data set, duplicates from the data set, and missing value. There are some techniques that we're going to use for all these three different ways of preparing data. After that, we do the data transformation. Maybe we need to reduce the instances, that's the records of the, let's say we have 20 taxpayers, maybe we should reduce it to 10. The algorithm will work better. Or the attributes are so many, we need to reduce it. We have something we call the dimensionality casing, which means the higher the dimension of the data, the more the algorithm will take longer and longer time to make a decision. So if I have two attributes that seem similar, I will drop one. For example, date of hired or date of birth and age. They're almost the same information. So I may either take one of them out. So after the data transformation, that's when our data is ready for analysis. Then that's the next step, apply the data mining algorithm. Then we get our result. We need to evaluate or interpret the result before we make a decision. So next example now is classification, how we can use classification in that direct marketing. Now, the goal here is to reduce the cost of mailing by targeting a set of consumers that we are sure they are likely to buy the new cell phone product. Here, we want to market a cell phone product, but we don't want to sell and mail to all the customers that has been making transaction business with the company, because that will cost a lot of money for the mailing. So here we have to do some data mining tasks based on the customer's purchasing behavior, or if we have the information by their income or their address, the demographic area they are living, we can use that to determine their income. If their address is a place where we know cost of living is very high, renting or mortgage is very expensive, or they are from a place where mortgage or renting is very cheap. So we need to know all this information for us to be able to be sure that we have a chance that this customer may buy the cell phone product. So again, data mining classification algorithm can be used in direct marketing to reduce the cost of mailing by targeting a set of consumers likely to buy new product. Now, how do we do the approach? First, we use the data for a similar product introduced before. So we can remember the data mining definition. We want to find a knowledge or a pattern in a data set. This data set will be an event that took place before, and it has been saved as a data. So the same thing applies here. We look at the customer's past purchases, and we see if they purchase, the customers that purchase a product that is similar to cell phone product, or maybe the costs are almost the same, then those are the customers we are going to target. Now we know which customer decided to buy and which decided otherwise. So we may have the class level buy or don't buy decision that form the class attribute. Then we collect various demographic, lifestyle, company interaction related information about all such customers. So data mining, our main ingredients is data. So if we want to predict about a customer buying an item or not, then we need to analyze every single data about that customer that is related to buying or not buying an item. Type of business, where they stay, how much they earn. Now we can use this information as input attributes to learn a classified model. Another example is fraud detection, like credit card. I'm using credit card always. All of a sudden, I use it in a way that is way deviate from my normal purchase behavior. And so we can use data mining to build a fraud detection model system. This will predict fraudulent cases in credit card transactions. So what is the approach? First, again, this is data mining classification. So always we need to have a previous historical data set with a class label. We know what happened. So here we use credit card transaction and information on its account holder as attribute. When does a customer buy? What does he buy? How often he buys on time? So these are all the information that we may need, or even more information. Then label the past transaction as a fraud or fair transactions. This will be the class level. So the past purchasing behavior, which ones are again a fair purchase or a fraudulent purchase. This forms the class attribute. Now we're going to apply a learning model on this class of transaction to build a model. Then later we can use a test set to test this model. So here we say use this model to detect fraud by observing credit card transactions on an account. So another application will be the attrition or churn. Attrition means, for example, if two companies, let's say a banking industry, we are Citibank and Chase Bank, a bank at Chase Bank. If I decided that, oh, I'm 80 years old now, I want to move out of New York City to Hawaii or some small village, so I need to close my account. This is not considered as attrition because I'm not moving from one bank to another. Now I'm a young 35 years old man. I'm still in New York City, but I find out that another bank is offering a good interest or good services than the bank that I'm using. So in this case, I decided to leave my bank and go to a new bank. This is called attrition. So data mining have a special program which we call the CRM, Customer Relationship Management software, that this software can monitor customers' behavior in an organization. And we try to take as much data from them, from the customers, and we input this data again to see how the algorithm will run on it, what decision to give us. So the approach to use here in order to avoid attrition or attrite is that we use detailed record of transaction with each of the past and also present customers to find the attribute. Then how often the customer calls, where he calls, what type of day he calls most, his financial status, marital status, etc. We need as much data as we want by the customer. Then we label the customer as a lawyer or disloyal. So our goal is to find a model for a lawyer, a loyalty. Because attract means I move from one company, go to my former company, competitors, and start business. Same business I was doing the previous organization. I'm going to a new organization, going to do the same business. Then we have attrition or customer attract. Another application is the Sky Survey cataloging. Here the goal again is to predict a class. The class is an images on the sky. We want to know if this image is a star or galaxy. Now, based on the shape of the image, and we may take this data using a satellite or a sensor, and we analyze this data. We have the training set that if this shape is this amount or this size of shape represent galaxy, this size of shape represent a star. So we are going to build a model as a training using the training set because we know star or galaxy. Then next we use the test set, which the class label, we don't have it. So now it's up to the model to predict whether the image is a star or galaxy. Again, you can see that so far we have looked through 4 applications and they are all in different field of studies or professional field, from retail marketing to star or galaxy prediction, to credit card fraudulent, and even to computational biology. We can build a model using classification to diagnose patients, a specific disease. So the approach of this survey catalog is that we need to segment the image, because based on the image size, we may know whether the image is a star or galaxy. So we have to measure the image attributes or the features. Here we have 40 of them per object. What we mean by 40 of them means the features or the attribute of the image is 40. Maybe the length, the width, the depth, the side, the weight, with the color, if it's possible, color can make difference. So the possible features is 40. So now we're going to model a class based on these features. This is a training set. We know the attributes, the data we have the class level also. So after we build a model, then we're going to get a test set to test how accurate the model is. So next we move to another data mining task, which we call the clustering. As we said earlier, clustering is the descriptive task. Classification is predictive. So here, the definition of a clustering is given a set of data points, each having a set of attributes, we want to measure the similarity of the data set. When two data sets are similar, we group them together as one cluster. If they are not similar, then we separate them to two different clusters. So here we say, given a set of data points, each having a set of attributes and similarity measure among them, find clusters such that data points in one cluster are more similar to one another, and data points in separate clusters are less similar to one another. So here we need a special algorithm that we can use to measure the similarities in the data set. So the most common and easy method is the Euclidean distance. Euclidean distance if the attributes are continuous, if the attributes are values. Or we can have other problem-specific measures, and we may discuss a lot of this when we start the clustering algorithm. So this is an example. You can see here we have 3 different clusters. So this here is based on space, so we measure the distance. You can see that the distance between each group is less if they are within the group than measure between 2 groups. The distance is very long. So we say the intra-distance are minimized. Distance within the group is very small, but inter-cluster distance are maximized. Distance between the clusters are very large or maximized. So let's go through some of the application clustering. We start with the most common, market segmentation. So here we have customers buying items, different customers, some buy low, high, any item, spend more or less money, etc. Now we can segment this data based on any of the customer attributes. If we want to use the customer location as the attribute, then we are going to have 2 or more segments based on where the customer from. If it's about their income, based on their income. If it's about their expenses or purchasing power, then fine. So clustering is to divide an item based on some similarity measurements. So the goal is subdivide a market into distinct subsets of customers, where any subset may conceivable be selected as a market target to be reached with distinct marketing needs. So our approach is we collect different attributes of customers based on their geographical and also the lifestyle related information. Then we're going to find the clusters of similar customers. So if 2 or more customers have similar attribute values, then we group them together as one cluster. If there's a dissimilar, then we group them separately. And another application is document clustering. The goal here is that we have a lot of documents we want to group the document based on the content of the document. If the document have more words or sports, then we group them together as a sports document. They have more information on medicine, we group all together. So we are grouping document based on the content of the documents. If they had the same content, then they will be in one cluster. If different content, they will be in different clusters. So here to find group of documents that are similar to each other based on the important terms appearing in them. So the approach here is to identify frequently occurring terms in each document. Then we form a similarity measure based on the frequencies of different terms. And we can use it to, again, to cluster. What we gain, information retriever can utilize the clusters to relate a new document or search item to cluster document. So if I'm able to cluster this document that this is sports, this is marketing, this is banking, the new record I'll get clusters. If they fall under any of these three, then it will be sent to that very location. If it's marketing similar or whatever value. Next, we go to the association rule discovery. So association rule, as we said earlier, is trying to find a relationship between two or more variables. But we have some threshold value here that we need to discuss: the confidence and also the support. We have a data set. We want to know that if you buy an item A, are you going to buy an item B? So first, I need to have the threshold value for support and confidence. And we may set it to, let's say, 0.5% or 0.5 value. It can be any value. But it shouldn't be, it should be like percentage from 1 to 100. So now what will happen is that if my threshold value is 3%, and I find for support, and let's say 5% for confidence, if I have the data set, I find the support and the confidence and they are lesser than these two values, it means there's no association. If they are the same or greater, then there's association. So here we say, given a set of record, each of which contains some number of items from a given collection, we should produce dependencies, kind of association. Dependence rule, which will predict the occurrence of an item based on the occurrence of other items. So example, we have a data set here. This is a supermarket data set. We have 5 customers. We can see the combination of items they buy in the supermarket. The first customer buy bread, Coke, and milk. The second customer buy beer and bread, etc. Now we may have a rule discovery here, but in order to discover this rule, again, it will be based on the confidence and support. So we saw, based on the data here, when a customer buy milk, he also buy Coke. The reason why, because we look at the milk and Coke together, we have 1, milk and Coke, and 2, and also 3. So customer 1, 3, and 5 bought milk and Coke. So that means the confidence, the support will be 3 over 5, 3 over all the total. But confidence will be, if we have a milk and Coke, we find how many people buy milk and they buy Coke divided by how many people buy milk. So here I'll say we have 1 milk, 2 milk, we have 4 milk at least, which means at least you buy a milk or more. It will be on the left side value because the milk will determine the Coke. As we are saying here, if you buy milk, you buy Coke. So in this case, the confidence will be milk and Coke again is 3, and milk alone will be 4. So it will be 3 over 4, 75%. The support was better. We can see that the support we have lesser value because it's 3 over 5, the whole database records. And again, we will go more detail on association, but right now we should understand the definition of association rule discovery. We want to know if we are given 2 or more items, by getting the first one, will it determine the second one to be around? So given a set of record, each of which contains some number of items from a given collection, produce a dependency which will predict occurrence of an item based on the occurrence of other items. So this is application example, marketing and sales promotion. The rule said when a customer buys bagels, he also buy potato chips. So potato chips is what we call the consequent, the right side, that determine what we have to do based on antecedent. So the bagels will be the antecedent. So consequent can be used to determine what should be done to boost its sales. And antecedents can be used to see which product will be affected if the store discontinues selling bagels. So if these bagels, potato chips work, then if customers stop selling bagels, the sales of potato chips will be going down less. And also we have the supermarket shelf management. The whole goal here is that we want to know that if a customer buys diapers and milk, then the third item he will buy will be bread. So don't be surprised if you find 6-pack stuck next to diapers. So we can use the association rule discovery in a supermarket to arrange how items are stored in the store. Another example is inventory management. A consumer appearance repair company wants to anticipate the nature of repairs on its consumer products and keep the service vehicle equipped with the right parts to reduce our number of visits to customer household. So that's our goal. A consumer appearance repair company wants to anticipate the nature of repairs on its consumer products and keep the service vehicle equipped with right parts to reduce on number of visits to customer. So this is discovery rule. If I get A, will B happen? So in this case, we can know the right of repair. So approach here is that process the data on tools and parts required in the previous repair at different consumer locations and discover the co-occurrence pattern. So we want to know the patterns. If A will B occur or if A will B and C occur. So the next will be the definition for sequential rules, which is almost, as we said earlier, close to association rule discovery. But association means I want to find association between two variables. If A will B and C. But sequential means if A, I want to see the order. Like here we say, if A and B, C will come. Then if C, then D is the output. So yeah, given it's a set of objects with each object associated with its own timeline of events. Now we should find a rule that predicts strong sequential dependency among the different events. So here we say rules are formed by first discovering their patterns. Again, this is a sequential dependency. Sequential means in order how the outcome is. If it's A next should be B, then C. Then we know we have output of D and E. Association, we don't care. It can be A, B, and C. There's a relationship among the three variables. Sequential, so it can be ABC, ACB, CAB. For association, the order doesn't matter. But in sequential, it's very important. If it's ABC, then AB before C, not ACB. No. So you have to be in sequential order. So example given here in telecommunication alarm logs. So you can see that this is very in order. We have example that inverter problem, excessive line current. So rectify alarm means we have fire alarm. Also in the point of sale transaction, computer bookstore, apply introduction to Visual C book and C prime prime. So there's an order that I have to, next book about will be the pair for dummies. It's a sequential order. athletic apparel store, I go to the Nike store, I buy shoe, the next will be racket or racquetball. Then there's a chance that I'll buy a sports jacket in sequential order. So next will be the regression. Regression also, as we said, is the same as prediction. We use it to predict a value of a given continuous value variable based on the value of other variables. If we remember college algebra straight line graph, that's the same concept, or the straight line function. Y equal to ms plus b, m is the slope, b is the y-intercept. And we may study this in statistics. Neural networking fields also we may discuss. And neural networking is a classification algorithm that also uses the functions. So example like predicting sales, you can see that all the prediction here will be values. Predicting sales amount of a new product based on advertised expenditure, or predicting the wind velocity is a value as a function of temperature, humidity, and air pressure. So based on air pressure, which is a value, humidity, which is a value, temperature, which is a value, we can predict the wind velocity. Or time series prediction of stock market prices. As the time changes, we can, and based on economic condition, we can predict the stock price. The next one is the deviation or anomaly detection. This is the concept of using a credit card example where we say that, for example, I'm in New York, I use my credit card always in New York, 99% of the chance, and also my purchases with my credit card is not over 1,000. All of a sudden, I'm in Texas or Florida spending 20,000 purchase an item in my credit card. This will be a deviation from my regular purchasing behavior or pattern. So deviation anomaly detection can be used for credit card fraud detection or network intrusion detection also. The goal of a deviation anomaly detection is to detect the significant deviation from a normal behavior. My normal behavior of using my credit card is I don't spend more than $1,000 in one purchase, and always in New York City or tri-state area, New York City, New Jersey, Connecticut. But all of a sudden I'm in California or Texas, spending 20,000, 30,000 purchase at a time. That will be an anomaly detection. I'm deviating from my normal purchasing again profiling. Now, challenges that is facing data mining today. One is the scalability. And I think scalability problem is being solved now using distributed computing environment, such as Hadoop with MapReduce. Scalability means we have a large scale big data. So now we can use the distributed system whereby over thousands of pieces maybe doing their part of the work. When they finish, they send it to the central command. Dimensionality, we have something called the dimensionality case. When you have a record or a data set with high dimension, the algorithm tend to perform poor. So we need to reduce the dimension. It's a challenge. Also, sometimes we have a very complex data or heterogeneous data, which is data with different dimensions, different formatting. We need to follow the right way to prepare this data, improve the quality of the data. Data quality is an issue also. And also data ownership in terms of privacy, security, protections, etc. So these are all challenges of data mining. So again, wish everybody the best. This is our last lectures for week 1. In week 1, again, we are covering chapter 1 of our course textbook, which focus on what is data mining, why we do data mining, different type of data mining tasks, and the challenges that data mining is facing today. And also where we can apply data mining tasks at different business organizations. So again, wish everybody the best. We have assignment for week 1. If you have any question, make sure to contact me, and wish everybody the best again. Thank you. Bye.